We are solving AIPMT questions of current electricity. Both are depending on electric power. Let us see what this first question is. An electric kettle takes 4 amperes of current at 220 volts. How much time will it take to boil 1 kilogram of water from temperature 20 degrees centigrade? See, what is given is the current of an electric kettle is 4 amperes. Voltage is 220 volts. We can write a formula V equal to IR. So I can get the resistance of that kettle. 220 equal to 4 into R. So resistance R equal to 220 by 4 ohms. I need not calculate it. Let us just leave it like this. Now what he is saying further is how much time is required to boil 1 kilogram of water from temperature 20 degrees centigrade, right? So what we need to do is, boiling means temperature has to be increased from 20 degrees centigrade to 100 degrees centigrade, because water boils at 100 degrees centigrade. How much heat is required for that? We can get it basing on the definition of specific heat. Specific heat is defined as amount of heat required to convert unit mass of substance by 1 degree centigrade. From here I can write dq as ms dt, where m is the mass, s is the specific heat, dt is the temperature. We know specific heat of water is 1 calorie per gram per Kelvin, but I want it in SI system. 1 calorie equal to 4.2 joules by 1 gram equal to 10 power minus 3 kilogram and Kelvin. So this is 1, 4.2, 10 power minus 3 becomes 10 power plus 3 and SI system, joule kilogram power minus 1, Kelvin power minus 1. So that is 4200 in SI system. So specific heat of water in SI system is 4200. Mass of water is given for you in 1 kilogram. Specific heat is 4200 in SI system. Change in temperature is from 20 to 100, that is 100 minus 20. So dq required is 4200 into 80 joules. This much of heat is required. Who will give this heat? This heat is given by this say power supply, that whatever is available through the kettle. So what we can say further? That implies this heat is supplied, by kettle. How much is that dq is? We know V square by R into T R dt. What is the voltage that is supplied? 220 volts into 220. By resistance we have already calculated, 220 by 4. By time how much we have to calculate. So whatever the heat required is supplied by the kettle. So this both the heat energies must be equal. We can equate them as equation number 1 equal to 2. What happens? 4200 into 80 equal to, dq is here, 220 into 220 by 220 by 4. So this denominator of the denominator comes to the numerator. 4 by 220 into time. I have just written this equation. So 1 220 can be cancelled. This 4 is of 20 times. This 1 0 also can be cancelled. So that implies time equal to, what is remaining is 4200 into 2 by 22. That's what is remaining, right? So 2 1s and 2 11s. So that is 4200 divided by 11. So that's value is 381.8 seconds. But the answer is in minutes. So 381 by 60 minutes. 6 sixes are 360. So it is little more than 6 minutes. So I can blindly choose 6.3 minutes as the answer for the problem. That's how we have to solve that problem, right? So let me go to the other part of the problem. Second problem is also there. This is also an AIPMT question. It says power dissipated across this 8 ohms resistor in the circuit is given as 2 watts. So what I can write? Power across 8 ohms can be written like, power has a formula. I want I, that's why I am writing in terms of I square R. Power is given as 2. Let me call this as I2. Let me call this as I1. So this is across 8 ohms now, so it becomes I2. So 2 equal to I2 square, and of resistance is across 8 ohms 8. So I2 square is 2 by 8, 1 by 4. So I2 equal to 1 by 2 ampere. So I got the resistance across 8 ohms I2 as 1 by 2 ampere. Then I1 is how much I have to calculate. But what we can see, this 1 and 3 are in series. So together they are 4 ohms. And at the bottom we are having 8 ohms. These two are in parallel. As they are in parallel, voltage is same. Voltage can be written like I1 R1, I2 R2. I1 I have to calculate. 4 is the combination of this 1 and 3. I2 I already have calculated 1 by 2. R2 is 8. This is the second part, this part. So this is 8 by 2 is 4. This 4 and 4 will cancel. That implies I1 equal to 1 ampere. So the current passing to this 4 ohms is 1 ampere. What is that 4? That is the series combination of this 3 and 1. As they are in series, they carry the same current. So I2 as you have got is half ampere. I1 is 1 ampere through 1 ohm. The same 1 will pass through 3 ohms also. That 1 and this 1 by 2 will join together and becomes an I. Now you want the power dissipated across 3 ohms, right? So power across 3 ohms is again the same formula. Power equal to I square R. Power across 3 ohms is, across 3 ohms what's the current passing is I1. I1 square into R. But I1 is 1 square. Resistance means as you want across 3 ohms, 3. 1 into 3 that is equal to 3 watt. So the power dissipated across that is 3 watts. That's how I have to solve the problem. So all these are simple basic formulas. You need to have that basic understanding of how to use the given data. Once if you know that, you will be able to get the answers. That's it. Thank you for watching.